What is up, chat? Today, or for this video, hopefully everyone is doing all right. This is a CSEC last minute preparation for chemistry. Right now, where I'm at very late. Think Terry just went to bed, I guess. He think he just finished up his stream, I guess. But Study Prep guys with you tonight. Today we're looking at chemistry. We're looking at a revision of the chemistry. We're looking at the revision of the chemistry syllabus. So let's take a look at that. Let me open up that right now for you. So hopefully everyone is okay. Hopefully everyone is okay out there. Let's see. Let me see. Let me see. Let me start this now. All right, everyone. Welcome back to Study Prep Chill Zone or Study Prep Csec. It's nice to be back with you. Chat, where are you right now? How is everyone right now? Everyone all right? This is a very late live stream. I don't usually do live streams this late, but I will do it for the sake of chemistry. Let me put this on screen. Let me put this on screen, guys. All right, guys. Welcome back to Study Prep Guys Chill Zone or Study Prep Guys channel. All right, so for the principles of chemistry or the general objectives when it comes back down to this area, is you should be aware that matter is made up of these components. Be familiar with matter. Appreciate that matter can be classified into both physical or chemical properties. Be aware of the different forces of attraction that exist between particles. Understand mole as a unit for comparison of amounts of water. Appreciate that properties of chemicals will affect the reactions, stuff like that. It's a lot of points. So let's look into the notes. So it says here, let's look into the notes. Hopefully everyone is with me with this one. I will not be doing the stream extremely long. It will only be around 50 minutes. Very short stream, very short. Me put up back this on screen. Let's start. So define relative atomic mass. So A equals mass number, B atomic charge, C charge, D for the number of items in the entity, and it could be interpreted in this sense. And let's look at the definition of an isotope or isotopy. Isotopes as atoms with are atoms with the same number of protons and different number of neutrons. The uses of radioactive isotopes, at least 3 uses of radioactive isotopes. Example for carbon dating, radiotherapy, tracers, peacemakers, and energy generation. Just things choking me right now, guys. So let's go down back with this here. Let's go up to the force point, so we could actually start at the start. Let's go up to the force point because we're going to try to go through as much as possible. Might go longer than 50 minutes. I don't know. So let's look into the force point. Evidence of or evidence obtained from practical work involving processes such as diffusion and osmosis. So in the use of salt or sugar to pest as a conservative. So something to note is that when we're utilizing we could utilize salt and sugar to control pests, garden pests as a preservative. I did make a video on that. You could look at the playlist at the in a later date. So let's look at the arrangement of particles, strength of force of attraction, and consideration of physical characteristics of states. This is an example of volume, density, and compressibility, which is the basic fundamental principles of elements and stuff like that. So types of solid solutions, something that you should be able to identify different types of solutions. Solid and liquid, solid and gas and liquid and liquid, gas and gas. Um, let's go down to some actually very important points. The notes, the atoms as consisting of three basic. So as I said before, atoms consist of three basic components: um, protons, neutrons, and electrons arranged in shells. No consideration of orbitals is expected. In the nucleus of an atom, it usually consists of electrons and protons. Electrons are negatively charged. Protons are positively charged. Neutrons are neutral. With the conjunction of a proton and an electron coming into play, we have something called a neutralization or reaction. So we have that out the way. So we did look at that. So let's look back at isotopes. I'm just repeating this. So isotopes are atoms with the same number of protons and different number of the same number of protons and different number of neutrons. So as I said before, neutrons neutrally charged, meaning that they are not positive or negative. They are kind of in between that. And protons are positively charged. Something that needs to be highlighted is the difference between anions and cations. So cations is positive ions and anions are negative ions. You just make sure I'm getting that right. All right, so let me just make sure I put out of the way. So cations and ions are two types of ions. Cations are positively charged ions with more protons than electrons, and ions are negatively charged ions with more electrons than protons. So there's a big difference between that two. So chat, are you with me? Are you with me on that? So yes, we have that out the way. So I was saying that cations and anions, there are two distinct things. Cations are positively charged, meaning that they have more positively charged ions, um, which is protons comparing to the negatively charged electrons. So we have ions are negatively charged, ions with more electrons than protons. We did highlight that. So let's go back to the syllabus. Let's go back to the document. So radioactive isotopes. We did look at carbon dating, radiotherapy, tracers, peacemakers, and energy generation. Um, yes. Now let's go down back to notes. So we'd have to look at mention of historical development of the periodic table, contributions from Mendeleev and Dominier, classification based on atomic number, structure, arrangement, and periods and groups. So we did look at the 2025 documents recently, the 2025 January paper too. I didn't have the energy, honestly, to actually make a full video on that because it requires a lot of energy, and it's late where I am. So let's look at mole and molar mass. So the mole is the amount of substance that contains 6.0 times 10 to the 3rd, which is the Avogadro's constant particles in that substance. Molar mass of 1 mole of a substance in gmol to the -1. So whenever we actually brought about by this here is always used. Now let me just look up this here, the Avogadro's constant. And honestly, it's quite big comparing to like the figures. Let me just put that up on screen here. This is the example of the Avogadro's constant. Right now, guys, I'm very sick. Hopefully that doesn't interrupt stream. But how is everyone doing? So let's go back down with the this is 2025 document. I only managed to answer questions because of time. So this is the 2025 chemistry paper two general proficiency. The this was 2 hours and 30 minutes. You have allotted time, and at least from the perspective of others, the paper wasn't that difficult. What you guys think in the chat? Was it difficult? I heard a lot of people say that it was relatively easy. So anyway, let's go down. So the term acid. Let's look at the term acid. I did make a video on this, but I'm just going through back it again. So an acid is a substance which dissociates in water. We just put disseminate so you could utilize that term also. Dissociate and disseminate is basically the same thing. Disseminate, disseminate in water to give H plus ions or hydrogen ions. So it disseminates in water in order to give hydrogen ions. And then we have the term normal salt, which is the substance that is formed with the H plus ions of is which is when is with all the H plus ions of a substance. Let me just think that down right there, good enough. So the substance that which is formed at, when all the H plus ions in acid are replaced by a metal, and I'm just using metals. There's other thing that could replace that, but for now we're just using the metal for simplicity purposes. Right? We're just using the metal for simplicity purposes because if you just want to use the simple terms. So the substance that is formed with all H plus ions of an acid are replaced by a metal. So let's move on down to a very interesting question. I'm just going over back this again and we'll call it a day right here. We'll call it right here. Let's see. How long was it? I've been streaming so far. 12 minutes, 12 minutes. Yeah, some time more. So let's go back to the syllabus. Miss, I could find this document, guys. Just give me a couple of minutes. Miss, I could find this document. I think this document will give us a bit more detail. Art, better. This is a better example now. Now we could have some time to go through the documents. So I could say the stream basically now start. So Ministry of Education, National Center for Educational Resource Development. This is the national scheme for secondary schools. This is in relation to chemistry. So let's start off just to make that notable. So let's start. So we're looking at organic chemistry now and natural gas, extraction of petroleum or crude, formation of biogas, right? So properties and uses of functions petroleum. So some properties and functions of physical properties and uses of fractions of petroleum, fuels, petrochemicals, and lubricants. Definition of cracking, types of cracking, discuss the need for cracking. Now let's actually go into some notable things that we could actually take into account. So it says here, a homologous series is a series of compounds with similar chemical properties. So if something does not follow the basic compounds of similar chemical properties, it's not a homologous series. And there's different types of homologous series, such as alkenes, alkenes, alkynes, and such like. I did have a document open looking into. Yes, I have it here. So I think this explains it the best. Or this explains it the best. So alkenes, they have high stability, Alkane have high stability. Alkene has reactivity. It's not as reactive as alkyne, but it is very reactive. Alkene has storage. Alkene has chemical synthesis, and alkyne has high temperature applications. So now let's look at the reactivity of the alkenes from the least reactive to the most reactive. We go up to that right now. I think this is very important notes. So for reactivity of alkene, and alkyne, alkane is the least reactive. Alkene is the least reactive. Alkene is the more reactive. It's like in between that spectrum of being more or less. We have alkyne, which is the most reactive of the homologous series. So let's look at boiling points. So if you look into the boiling points, alkene has a higher boiling point. Alkene has like a variable between of the highest boiling point and the lowest, and alkyne has the lowest boiling point out of all the three. Sorry for that, guys. I'm doing very sick right now. So back with the environmental impact of the homologous series now of alkene, and alkyne. Alkene, which has these CO2 emissions, alkene has the smog contribution, and the alkyne has toxic byproducts which could actually affect the atmosphere. And a very important topic on the disease syllabus is polymerization, which really incurs the issue of environmental impact. We did talk PVCs and stuff like that could negatively affect the environment, which is a byproduct of the polymerization process, which usually has a chain of reaction. So alkene, from the production of alkene, we have the natural gas, alkene, the industrial production, and alkyne, which is synthesized. So from alkene, we have the production of natural gas or natural CFCs, which is chlorofluorocarbons, which is a we use it in our houses, such as sprays and whatnot. Let's go back to the document and detail right now. So characteristics of the homologous series, they have the same general formula. They show similar chemical properties. Each member differs from the previous by CH2. They show gradation in their physical properties. And something that needs to be highlighted is the ability to differentiate between molecular, condensed, and structural formulae. If anyone has anything in the chat, you could type now. I'm going to open the chat. So after I open the chat, I will read it for a couple of minutes. And if there is no questions asked, I will have to move on. I will can't see your chat after I move on. So I'm going in now. I'm going to see your chat now, guys. Any question, guys? Any questions on anything? If you have any question, guys, you could leave it in the chat below. So we're moving back to the topic at hand, guys. If you're not responding, you do not ask question now. It's a very late live stream I'm doing right now. This is for the people who are staying up very late, like me. So let's move on. So we're going into the properties of alkenes or alkanes. So properties of alkanes, which is the reactivity of alkenes, combustions, balance equations, and balance. Let's move on. That's just notes. So there are mainly three reactions of alkenes, which includes combustions, addition, and substitution. So out of the whole homologous series, as I said before, there are really different between alkenes because, as I said before, if you could look back to the diagram, you could see that alkenes is very special since it creates natural gas. right? So alkenes as fuels and solvents, and alkenes as the starting material for a whole range of polymers. As we could see right here from the diagram, the properties of alkene. So something that needs to be noted is that the difference between alkenes and alkynes, remember that properly, I probably pronounced that incorrectly, is there something called a single bond, a double bond, and a triple bond, right? So alkene have something called a single bond, an alkene, which is ethene, um, has a double bond, and an alkyne has a triple bond. Make sure that's right. So let's look back at that. The alkenoic acid, which has a double bond, the ester, which usually has the OR, which is signification of that, which is the ester. And esters are usually lubricants such as perfumes or sweet smelling. They're mainly sweet smelling. That's the main way you could figure out what is an ester. And for alcohol, this is usually the physical, or this is usually how it's represented. So we could put that right on there. Let me view it more to this so you could take a proper look. So alkane, single bond with four hydrogen bonding, which has a four hydrogen bonding, and we have the alkane, as I said before, alkane, which has a single bond, and alkene, which has a double bond. So that's how we could actually differentiate between the two. So let's move on. We're just brushing through. So let's look at some of the uses of ethanol to produce alcoholic beverages as solvents for paint, varnish, liquid soap, and toiletries. We use ethanol to produce alcohol. We use ethanol as a preservative, and we even use it in some doctoral perspectives, whereby we could actually utilize it for pharmaceutical products such as painkillers, such as we use it to destroy bacteria in cases of a cut or a sprain or somewhat of the sort. So the final format I will look at, because I don't think I have enough time to go through everything, is fermentation, right? So fermentation is a reaction by which carbohydrates such as starch or sugar are converted into ethanol, which is a process through of starch equals to hydrolysis equals to less complex sugar equals to hydrolysis, simple sugar glucose fermentation, and then finally ethanol. So I will close out this video for now. I didn't want to make it too long because right now where I am it's very late. So guys, see you later. Hopefully you enjoyed the video. Hopefully you learned something, even if it's a small thing. See you guys on the next video.